Welcome to 5.5, Evaluating Quadratic Functions. A lot of what we're going to do today is actually review from other chapters, at least this first example here. And then we're going to talk about the discriminant we can, or how we can use the discriminant to determine if there's any x values, real x values, for the y values that are given to us. So we'll talk more about the discriminant aspect. But let's go ahead and just dive right into this first example. Given the function f of x equals 5x squared plus 8x minus 7, the first thing we want to do is find f of negative 3. We've dealt with function notation before, so I want you to pause the video, try part A, and then unpause it when you're done to check your answer. Okay, hopefully you got 14 like I did. So this is, again, just a substitution. Wherever there's an x, I'm going to substitute with a negative 3. Now notice, I use parentheses whenever I'm making a substitution. That allows me to keep my order of operations intact. So squaring the negative 3 first, all right, and then continuing from left to right. If you have questions on it, let us know. Notice the wording of part B. Find x when f of x equals negative 3. Now, notice there's no placement here for x, so we need to now set the equation equal to 3 and solve for x. So step number 1 is set 5x squared plus 8x minus 7 equal to negative 3. And we want to find what x is. So that is our goal. So what I want you to do now is I want you to pause this video and solve for x. Okay, how'd you do? So hopefully you recognized step 1, well, we set the equation equal to negative 3. We're going to solve for x. In order to solve a quadratic, we need it to set equal to 0. So I added 3 to the other side. Now, if it's a quadratic, our number one goal is to factor if possible. This is factorable. 5x minus 2 times x plus 2 equals 0. Make sure we're showing all of those steps. Setting each of those factors equal to 0, we get x equals 2/5 and x equals negative 2. So we end up with two x values when f of x equals negative 3. If we wanted to take it a step further and use these values when we're graphing, we know that we've got two ordered pairs. X equals 2/5 when y equals negative 3, and x equals negative 2 when y equals negative 3. This is just an extension, right, when we're getting into graphically talking about these quadratics. Moving back to example C, find the x-intercepts. So before we do that, we have to think about, well, what is an x-intercept? What do we remember about an x-intercept, right? So it's the x value when y equals 0, or in this case, when f of x equals 0. So it's very similar to example B. So step number 1, we take our equation, 5x squared plus 8x minus 7, and we set it equal to 0. Okay, I want you to go ahead and solve this quadratic. If you can factor it, factor it. If not, think about other methods that we've learned. What we should have noticed is we can't factor this quadratic. So we need to go to the quadratic formula. So remember, it's equal to negative b plus or minus the square root b squared minus 4 times a times c, all over 2 times a. When we clean up 8 squared minus 4 times 5 times negative 7, you get 204 underneath that radical. So negative 8 plus or minus the square root of 204 over 10. Biggest perfect square that goes into 204 is 4, and it goes into it 51 times. Square root of 4 is 2. So now our last step here is we need to simplify. So what we should notice is the negative 8, the 2, and the 10 all have something in common. They have a 2 in common. So we can take a 2 out of everything. So we're going to get x is equal to, taking a 2 out of negative 8, we're going to be left with negative 4, plus or minus. Taking the 2 out of 2, we're just left with 1. Square root of 51, all over 5. So the x-intercepts that we have are negative 4 plus the square root of 51, all over 5, and negative 4 minus the square root of 51, all over 5. This last example is going to use the discriminant to tell whether or not the function ever has the given values of y for real values of x. Okay, so just a reminder of what our discriminant is the discriminant is the part underneath the square root symbol within the quadratic formula. So it's the b squared minus 4ac portion. All right, so if we want to use the discriminant to determine whether or not this function ever has any y values or any has the given values of y for any real values of x, the first thing we're going to do is set the equation equal to that y value. So our equation is 4x squared minus 7x plus 2 equals that y value of 5. Okay? And before we can then just use our discriminant, we need to set it equal to 0. Okay? So set equal to 0. So we're going to subtract the 5, and we're going to get 4x squared minus 7x minus 3 equals 0. Now we can go ahead and use our discriminant. So remember the discriminant b squared minus 4ac. So let's set that up. So we have negative 7 squared minus 4 times negative 3. So this becomes 49 plus 48, which we get a grand old 97. So our discriminant is 97. However, the question didn't ask for what our discriminant was. It says use the discriminant to tell whether or not the function has given values of y for real values of x. So what do you think our conclusion is going to be based on the fact that we have a positive discriminant? Okay? So think about that, and then think back to the notes from the other day. Since this is positive, we will have two real, and since 97 is not a perfect square, we could even say irrational x values when y equals 5. I'm not finding what those x values are. I'm simply using the discriminant to determine whether or not we have any real x values for that y value. Okay? All right, I want you to try part B. Now, you try when y equals 3, use the discriminant and make your conclusion about the x values. Pause the video, give it a try, and check back when you're done. Okay, what'd you get for your, or using that discriminant value when you set y equal to negative 3? Well, remember, step 1, set it equal to 0 after you've set it equal to negative 3. Using our discriminant, I got negative 31. So since negative 31 is less than 0, our conclusion can be there are no real x values when y equals negative 3. Okay? If we got our discriminant to equal 0, so if the discriminant equals 0, how many x values do we have? We would have one real x value. Okay? If it's greater than 0, we have two real x values. And if it's less than 0, we have no real x values. Very similar to before. If you have any questions, let us know.